All right, now we're going to talk about lists, which are sequences of multiple items. Lists are great for holding and manipulating sequences of data. As you will see soon, sequences of data come up in a variety of useful situations. Often, your program will not know how many pieces of data you have until it reads the data from its input source. For example, it might read a CSV file and need to put one piece of data per row of the file. When you write the program, you often cannot say how many rows are going to be in the input file, especially as you likely want to run the program on many different inputs. A list is great for this sort of situation, as you can add more items to a list once it is created. To start our introduction to lists, let us see a list literal. If we just want to write down a list with the numbers from 1 to 5, we can do so by writing them in square brackets with a comma in between each element. Another thing we'll mention as we get started is the Python documentation. You can consult it for many useful details on methods to operate on lists. However, to really understand what is going on with lists, we are going to need to introduce a new concept that we have not seen before. To see why we need a new concept, let us take a look at a small bit of Python that uses lists. Here we have a line of code that sets A to the list with 1 and 2 using the list literal syntax that we just showed you. When we say B equals A and A.append 3, the append method places an item onto the end of a list. Remember, we said that we can add more elements to a list once it is created. This method is one way to do that. The dot operator here is also new. It means inside of. That is, we want the append method inside of A. We are appending to that particular list rather than some other list. This dot is related to the idea of objects, which we will learn about later. So this line says, add 3 to the end of list A. Given that, what do you think this code prints? It will be hard to get the right answer as we do not yet have all the semantic concepts we need. Let us take a moment to see an incorrect way to execute this code. While it may seem strange to look at it the wrong way, what we are about to show you is a reasonable and common misunderstanding that sets us up to learn how it actually works. As usual, we begin with an empty frame and an execution arrow at the start. We create A and set it equal to the list 1, 2. Next, we copy the value of A to B. Then we append 3 to A, putting another item at the end. Then we print A, which is the list 1, 2, 3. Then we print B, which is the list 1, 2. However, if we try running this in Python, we see a different and perhaps surprising result. A is 1, 2, 3 as we expected, but B is also 1, 2, 3. What has happened here? Our mismatch with Python comes from the fact that we have the wrong semantics. We drew an incorrect picture. So now this raises the question, what are the correct semantics? The correct semantics are that the actual list is outside of any frame. It is in an area of memory called the heap. What actually goes on in the boxes for A or B are an arrow pointing at it. This is called a pointer or a reference. Let's see how we correctly do the first statement. Now you can see that the value in A's box is an arrow pointing at the list 1, 2, and that the list is outside the frame. Now when we do B equals A, we copy the value in the box. However, that value is an arrow pointing into the heap, so we end up with this picture. Now when we do A.append 3, we put 3 on the end of the list that A is pointing at. Next we print A, which is 1, 2, 3. Finally, we print B, which is 1, 2, 3. Okay, now that you have seen the right semantics for lists, take a moment to try to execute this code yourself. After you do it, we'll go through it together, but it will help you to learn to have tried it yourself first. We'll start at the start of main. We make the list 1, 2 in the heap and make A point at it. Likewise, we make the list 33, 44 in the heap and make B point at it. Next, we are calling a function, myFn of A and B. Calling a function uses the same semantics you have seen before. We create a frame and pass parameters. The first parameter is A. What is the value of A? It is an arrow pointing at the list 1, 2. So we copy that arrow into the box for the first parameter, list 1. Likewise, the second argument is B. What is the value of B? It is an arrow pointing at the list 33, 44. So we copy that arrow into the box for the second parameter, list 2. We record our call site location and move our execution arrow into my function. Now we append 42 to list 1. This alters the list in the heap so that it now has 42 at the end. Next we do list 2 equals list 1. Notice that this assignment changes the box for list 2 to point where list 1 is pointing. We copied the value from list 1's box into list 2's box. Next we do list 1 equals 4, 5, 6. This makes a new list in the heap and puts a reference to it in list 1's box. The last thing this function does before it returns is append 99 to list 2. That alters the list in the heap, putting 99 at the end. The function now returns list 1. What is the value of list 1? It is an arrow pointing at the list 4, 5, 6. We are returning to call site location 1. As we have seen before, a function call evaluates to the value returned by the function. Here that value is an arrow pointing at the list 4, 5, 6. So when we return, that is the value of the right side of the assignment to C. Now we can assign that return value to C. In particular, C points at the list 4, 5, 6 that is in the heap. Now we are ready to print A, print B, and finally print C. Now we are done with the function main and it will return, destroying its frame. We know that this may seem a bit tricky, but remember that drawing a careful picture and thinking carefully about the semantics of the code will help you understand what your code is doing. We want to note that understanding references helps us understand an important distinction between two ways that methods can operate on lists or other objects. Some methods modify the object. You have seen append on lists, which adds an item to the end. There are many others which also modify the object, such as insert, remove, or sort. As these modify the object, any other reference to the same object will see those changes. Other methods leave the original unchanged but return a value. For example, the copy method makes a copy of the list. The sorted function takes a list and returns a sorted version of that list. However, it leaves the original unchanged. Now that you know about references, we are ready to learn a lot more about lists.